This is what happens if you take two Tesla coils, direct the high voltage top sides inward toward a plasma globe or even a light bulb, and drive the Tesla coils in opposition to each other, 180 degrees out of phase. While invisible, the resulting high voltage RF electrical field can be observed indirectly by the complex plasma discharge patterns seen inside the ionized bulbs. Here's a circuit diagram of a Tesla coil. So there's a primary coil of a few turns, a secondary coil of many turns, and that transforms the high-frequency alternating current input into a high-voltage RF output. Experimenter Eric Dollard suggested putting two high-voltage output terminals aimed inward, driven 180 degrees out of phase, and that lends some interesting and complex plasma discharges within bulbs placed in the strong electric field between the two terminals. He called it the Cosmic Induction Generator, or a cosmic light bulb, because inside the bulb, the plasma discharges have fractal patterns and natural forms that look like the sort of thing you see in lightning strikes or pictures of the cosmos. This blue bulb came from a novelty plasma lamp. It's shaped like the planet Earth, and inside the glass, there's like a phosphor coating. Here you can see at low power, it just has sort of a cloudy, misty little vapor stripe in there, but then at high power, it starts arcing from side to side and up around the phosphor coating inside the glass, and then you get lightning strike sort of patterns and fractals galore. Now we go to a toy plasma globe. It's got a argon with a bit of neon inside it. Now I've taken the bulb and flipped it upside down, removed the middle electrode part, and here it is slowed down to 10% speed. If you try and track the different directions that the lens are spinning, it seems like some counter-rotational stuff going on. And then once the left and the right side start really arcing across the middle, you begin to see the paint boundaries between the different branches. And next up is a 5-inch Xenon globe. It came from one of those plasma toroid kits. You can get them on eBay. And it's just Xenon inside a glass sphere. And at low power, you just see a misty sort of glow discharge. Dots start forming to the left and right. And if you look closely at the arc going across the middle, it's actually itself made of little dots that sometimes can be distinguished. And I think the arc is heating up the gas, and that's what's making it rise and wobble left and right in there. Slowed down to 10% speed. Back to full speed. And here I've got a magnet on a stick that's brought into proximity. You can see it affects the glowy, misty part a little bit, but most of the magnet's effect is on the thick arc going through the high current part, because the magnetic field and the current should be of a kind. So that makes a bit of sense. the effect is so local that it can be hard to tell, but here I'm trying to rotate the magnet and see what the magnetic polarities do. See, the arc comes in and makes a bit of a kink. This is just a regular globe incandescent bulb, but wow, what a windstorm in there. Get these little pink purplish zap discharge strikes up against the glass. This is a little comb electrode from one of those Violet Wand cosmetic products, a little argon bulb, and the different teeth light up due to a standing wave pattern in there, and which teeth are lit can vary from one firing to the next. Now, another noble gas inside a sphere, you'd think a neon globe would be interesting as well, but it doesn't do anything except just glow bright orange, unless a magnet is brought up next to it, and then it makes a bit of a crater. Other than that, not much complexity other than the gorgeous orange glow. Anyway, thanks to Eric Dollard, the eMedia Press guys, Agassiz and Griffin Brock for the tips and feedback, all my Discord buddies, the people talking about this thing on Thunderbolts forum, and Ben and Susan from thunderbolts.info. And thanks to all of you for watching.